In this lesson, 10.1, we're going to look at inverses of simple quadratic and cubic functions. Before we get started, you need to make sure that you review your notes from lesson 1.4. You can also rewatch any videos that I posted on Google Classroom for lesson 1.4. This was the second lesson that we learned in Algebra 2, so you'll have to look back at September for that information. The goal for this lesson is, can you write and verify inverses? So something that you're going to have to keep in mind, we're going to have to restrict the domain for quadratic functions. Why? Because a quadratic is a many-to-one function, so its domain must be restricted in order to find the inverse. If you don't know what many-to-one means, you can look at your interactive lesson on 1.4 for that explanation. Basically, what this means is that we're going to make sure that we don't have to square root negative numbers because we don't want to deal with imaginary numbers. We're just wanting to deal with real numbers. So, starting off, we're going to write the inverse. Okay. And we're going to need to make sure that we restrict the domain. Okay, for the quadratics. Okay. All right, so we'll start off with quadratics first. So let's say I have f of x equals 2x squared plus 1. All right, looking at our notes from lesson 1.4, we first need to switch the x and the y. And you can say, well, you don't have a y written. Remember, this is the same thing as a y. All right, so I'm going to switch them. So instead of a y, I'm going to switch to x. Okay, instead of an x, I'm going to switch to the y. And now I'm going to solve for y. Okay, so I'm going to subtract 1 over. So I get x minus 1 equals 2y squared. I'm going to divide both sides by 2. So now I have y squared equals x minus 1 over 2. And then I'm going to square root both sides. Okay, so our inverse, we're just going to look at the positive value. We're not going to put plus or minus. We get the square root of x minus 1 over 2. And then I need to replace the y with the function notation, but remember the inverse has that negative 1 to it. So instead of a y, I'm going to say f inverse of x equals the square root of x minus 1 over 2. Okay. Now, I didn't restrict the domain, so I need to make sure that I restrict the domain. I'm going to restrict the domain so that the x's are greater than or equal to 0. Okay, so we're restricting them to the positive values so that we won't have the many-to-one function. Now when I look at this particular problem, we want to make sure that we restrict the domain. Remember, we're basically trying to make sure that we don't get a negative number underneath here. So you can think about some numbers. If I plug in 0 here, 0 minus 1 is negative 1, divided by 2 would still be a negative. So I don't want to have a negative 1 in there. If I plug a negative 2 in there, negative 2 minus 1 is negative 3, divided by 2 is still a negative, so I don't want negative 2 or negative 3. Let's say if I plug in a 1. 1 minus 1 is 0, and 0 is not a negative number. So we're going to restrict the domain. We want the x's to be greater than or equal to 1 so that we don't get those imaginary numbers. All right, let's look at another example. Let's say I've got f of x equals 0.2 x squared. Okay, I'm going to restrict the domain to just the positives. Okay, and now I'm going to, first of all, rewrite this, or remember that this is a y, and now I'm going to switch the x and the y. Okay, so that's going to give me, instead of y equals, that's going to give me x equals 0.2 y squared. Now I'm going to solve for y. Okay, so I'm going to now divide this by 0.2. And so I get y squared equals x over 0.2. And then I'm going to square root both sides so that the inverses cancel. Okay, and then the only thing that we're going to remember to do is that we're going to replace the y with the function notation. So we're going to say the original function was f of x, so our inverse is going to be kind of like with this negative 1 exponent, so it's read as f inverse of x. So we're going to say f inverse of x is the square root of x over 0.2, and I need to restrict the domain, and I want to keep this to being a positive number. So if that were a negative number, then that's going to create a negative number underneath here. So I want the numbers to be bigger than or equal to 0, because 0 divided by something isn't going to give me a negative number. If I pick a number bigger than 0, like 3 divided by that number is not going to give me a negative number, and I won't have to worry about square rooting a negative. All right, let's try one more. F of x equals, let's do x squared over 5. And again, I'm going to restrict the domain. The x's are going to be greater than or equal to 0, so we don't have that many to one function. All right, so start solving. This is the same thing as y. So we're going to switch. Okay, and start solving. So now I'm going to multiply both sides by 5. So I get y squared equals 5x. And then I'm going to square root. Okay, so I get that y equals the square root of 5x. We're just going to replace y with the inverse notation. And we're going to restrict our domain. And we're going to say x's have to be greater than or equal to. I'm trying to keep this to being positive numbers or non-negative numbers. So the x would have to be greater than or equal to 0. Okay. All right. You don't need to restrict the domain for cubics. Why? Because you can cube root a negative number. Okay. All right, so let's say I give you f of x equals, let's go x plus 1 cubed over 4. All right, so again, you're going to switch the x and the y, so that's a y. I'm going to switch them. Okay, and now I'm going to solve for y. Okay, so I'm going to multiply both sides by 4. So I get 4x equals y plus 1 cubed. How do I get rid of a cube? I cube root both sides. So I've got the cube root of 4x equals y plus 1. Get y by itself, I need to subtract 1. These are not like terms, so my answer is the cube root of 4x minus 1 equals my y. And then we're going to replace our notation with the inverse of the function. Equals the cube root of 4x minus 1. Make sure that minus 1 doesn't look like it's underneath that root symbol. All right, let's look at you verifying the inverses. Okay, we need to verify that f of f inverse equals x, and we need to verify that f inverse of f of x equals x. So I'm basically telling you the answer. When you simplify it, you should get it down to an x. So it is the work that I'm checking to make sure you're doing it correctly. All right, so I'm going to give you a problem. I'm going to use one of our previous examples. So we're going to verify the example where we had x squared over 5 and its inverse, which was the root of 5x, are inverses. Okay, so what that means is that basically we're going to take this equation and we're going to substitute it into the variable here and simplify. So we're going to take f inverse of x and we're going to plug it in there. So I'm going to say x squared over 5. I'm taking this f inverse and putting it in that spot. All right, I know that the answer has to equal x. I just need to prove that. So you have to correctly simplify this. You can't just cancel everything out to give you an x. It has to be done in the correct stages. So they have a square root that they are squaring. So the square root and the square will cancel each other out. So I get 5x over 5. So I can cancel out the inverse. A root and a square will cancel each other out. Now what can I simplify? Well, a 5x divided by a 5, the 5's will cancel, leaving me with just the x. I should only see you canceling out one thing in each stage. I don't want you canceling it all out in one just so you have an x. It doesn't prove to me that you know how to simplify. So we've done that. Now we need to do f inverse of f of x. So I'm going to write down f inverse, which was 5x, but I'm going to put in its place what f of x was, which is x squared over 5. So now I am square rooting 5 times this fraction. And again, I know that the answer is going to equal x, so you have to accurately tell me what to simplify here. So if I'm taking 5 times a fraction, and I have a 5 in the denominator, this 5 is going to cancel out with that 5. So that's going to leave me with the square root of x squared. And now I can simplify that the square and the square root are going to cancel, and I just now have my x. Okay? So you should only have one thing canceled in each stage. In this last example, we're going to verify f of f inverse and then f inverse of f of x. So we're going to first do f of f inverse of x. So you want to go to the original f function, which was this one, and write it out. But wherever there's an x, put a parenthesis, square it, and add 4. Now go to f inverse and plug that in there. Okay, again, I know that this is going to equal x, so it is the motions in between here that I'm checking. So if I have a root and I'm squaring it, the root and the square will cancel each other out. So now I am left with x over 4 plus 4. Okay. Well, if this would have been times 4, then those would have canceled. But this doesn't cancel to x. So f of f inverse of x does not equal x. They aren't inverses, and we can just stop with the problem.